Welcome to David Alexander Maths Tuition. This is Chapter 3C, Simultaneous Equations on Graphs. So we don't need to solve these equations algebraically. If we've got a graph, all we need to do is see where they cross, where they intersect. So here we can see that they cross at 2, 6. So when these, there we have the solutions. Well, x is 2, y is 6. Easy peasy. Okay, so again, we don't need to, we could write that x squared minus 2 equals 2 and try and rearrange and solve, but it's so much easier. Just look at the graphs and see where they intersect. Well, here they intersect at 2, 2. So that's one solution, and the other one is negative 2, 2. Find the coordinates of the points where the line with equation y equals 14x take 18 intersects the curve with that equation. So, okay, so we've got a line meeting a curve. It does say points plural, so I'm assuming it meets it twice. Okay, well, we could draw a graph of it, but here we just need to understand that the points of intersection are just doing some simultaneous equations here. So if y equals this and y equals that, then we can make the two things equal each other. So 14x take away 18 equals x squared plus 3x plus 6. I want to make the left hand side equal 0, so I'm going to subtract 14x, so that's going to be plus 11x. I'm going to add 18 plus 24, and that equals 0. So if I factorise, this will be x plus 8, x plus 3 equals 0, and if these factors equal 0, then one solution is x is negative 8 and x is negative 3. And what are the y solutions? Well, let's go back to either of these equations. Let's do the top one. So 14, the y solutions are 14 multiplied by the x solutions, take away 18. So it's going to be 14 times negative 8 minus 18. And sorry, I've messed that up completely. So 14 multiplied by minus 8 minus 18, not 118. So that is minus 130. And 14 times negative 3 minus 42 minus 18 is minus 60. Okay, so what are the coordinates? The coordinates are minus 8, minus 130, and negative 3, negative 60. Determine the number of points of intersection for this pair of simultaneous equations. Okay, so what this question is asking is, this is the 3x squared plus 7x minus 10. This is the 12x minus 5. Are we getting two solutions? Are we getting just one solution? Or are we getting no solutions? So if y equals this and y equals that, then 3x squared plus 7x minus 10 must equal 12x take 5. I'm going to subtract 12x from both sides. I'm going to add 5 to both sides to make it equal 0. Now the number of solutions, if you cast your mind back to chapter 2, it's all about the discriminant. What is the value of the discriminant? So what is the value of b squared minus 4ac? So a is 3, b is negative 5, and c is negative 5. So b squared is minus 5 squared, so 25 minus 4 times 3 times minus 5. 4 3s are 12. 12 times 5 is 6, so it's minus 60. 25 minus 60, so 25 plus 60, 85. So b squared minus 4ac it's not important that it's really this number. The number's not magical. The fact is it is positive. So since the discriminant is positive, since the discriminant is greater than 0, that means we are getting 2 points of intersection. If b squared minus 4ac was negative, we would have no solutions at all, and if it was exactly 0, then we would have just one solution.